Let's look at another view of this whole rotating around an axis issue. Let's say I have this curve, which is x over 3 quantity squared, and I'm going to rotate it, but I'm not going to rotate it around the x-axis like I've been doing with my other curves. I'm going to rotate it around the y-axis, so make kind of a bowl shape. So I'll do a symbol that I hope gives the idea that we're rotating around the y-axis. So what can we do to compute the volume of the bowl shape that we get by rotating this around the y-axis? First, we should draw a differential element, a very thin slice of something. Before we had done our thin slices this way because we were rotating around the x-axis. Now maybe since we're rotating around the y-axis, we should do our thin slices this way. So we're going to get kind of the other side of the parabola here, and we're going to have a thin disk that wraps around like that. So that's my differential element. And then we'll just add up the volumes of a bunch of those, right? Before we had the formula volume of each element, add it all up. So we could say integral from A to B, the area of the base, like the planar area, times the thickness. And that was true when we were integrating with respect to x. Now we'll just be integrating with respect to y. We'll just be slicing it like that. So this will be the integral from y equals a to y equals b. Area of the base would be pi times the radius at a particular y value rather than the radius at a particular x value. So pi times radius at this y value. Squared, so pi times radius squared is the area of the base. And then what should we call the thickness of that disk? Well, we used to call it dx. How about we call it dy? Seems okay. So now the question is, if my y value is very small, near 0 here, I have a very small radius of my bowl. If my y value is very large, then according to this shape I have a very large value of my radius. What is that value of the radius? Is it just x over 3 squared? Is it y over 3 squared? Well, this formula tells you for a particular x value how high up you go. But we want to say, based on how high up I am, how far out from the y-axis do I go, which is an x value. So this radius at this x value, I need an expression in terms of y. You give it y, it gives you an x value. So I need something like x equals something or other involving y. So I'm going to take y equals x over 3 squared and solve for x, because I say I need x equals something. So how would you solve this for x? Square root on both sides. So you get square root of y equals x over 3. And then what? Multiply both sides by 3. So 3 root y equals x. I'm going to leave as an open mystery here. Do I need a plus or minus here, or a plus or minus there, or maybe no plus or minus at all? It turns out I don't need it. Whether it would hurt to have it there is another issue. So this tells me the radius, x is a distance from the origin horizontally, which is a radius in this drawing, for any particular y value, how high up I am. So my integral is the integral from y equals something to y equals something else, pi times 3 root y squared dy. I haven't exactly specified where to start and stop yet. I was all about the shape and thinking about switching the x and y axes. Let's go back and specify something. Let's specify that here we're starting at 3 root 10. And if you put 3 root 10 into here, what? The 3 cancels the 3, I get root 10 squared, which is 10. So I get that. So I can say here y equals 0 to 3 root 10. Amazing how that worked out so nicely. And is this basically the same thing we had in the other video, just with the letter y instead of the letter x, because I'm rotating the same curve, except the curve is now flipped. And I'm rotating around the y-axis instead of the x-axis. So that's another view, rotating things about the y-axis instead of the x-axis. And now we'll go look for other views.